Welcome to the Tropolink application tutorial videos. We hope these videos help you make the most of the features available on Tropolink. In this first video, we will explain how to launch a trajectory calculation and perform an initial exploration of the corresponding outputs. Once logged into Tropolink, you arrive on a dashboard, which gives you access to studies that have already been conducted or are currently in progress. Each study contains one trajectory calculation and possibly several connectivity computations. At the top right of the page, you'll find several tabs, notably the Trajectory tab, our focus in this video, as well as the Python Analysis and the R Analysis tabs, which provide access to Jupyter notebooks for exploring trajectories and connectivity outputs generated by Tropolink. In the Trajectory tab, you begin by giving your trajectory calculation a name and a brief description. You then need to provide the start or arrival dates for forward or backward trajectories, the geographic start or arrival sites, and the high-split tuning parameters. To provide dates and sites, you can prepare two text files beforehand, one for the dates and one for the sites, written in specific formats. You can load the dates by clicking Import Dates. You can add or delete dates as you wish. Similarly, you can load the sites by clicking Import Coordinates. You can also add a site by entering its code, label, latitude, longitude, and start or end altitude in meters above sea level. Lastly, you need to tune the high-split calculation. Enter a positive value for trajectory duration to generate forward trajectories and a negative value for backward trajectories. For example, here we choose forward trajectories lasting 12 hours. Then specify the start or arrival time in UTC format, followed by the top of model domain parameter, indicating the maximum altitude of the trajectories, and finally the vertical motion method the model should use. The first method is a valid default for many applications. To assist with setting up your trajectory calculation, you can display small pop-up help windows. To start the computation, simply click Run. This action takes you back to your dashboard, where you can see your trajectory study in progress. It initially appears as pending. Once your study is picked up by the computing cluster, you can monitor its progress by looking at the numbers of dates for which trajectories have been calculated out of the total. Here, 20 dates. Once the trajectory calculation is complete, you can go to its dedicated page where you will see the dates, geographic sites, and high-split tuning parameters. On this page, you can download the study specifications in JSON format. You can also download the high-split generated tdump files containing the calculated trajectories, one file per date. Tropolink also lets you configure a new trajectory simulation based on previously conducted studies. You can do this using this box, where you can select a study from your dashboard. For example, by selecting the Mediterranean study, you retrieve the dates, sites, and trajectory parameters associated with it. Alternatively, you can upload a JSON file like the one previously downloaded. You'll see that the new input data appear. You can modify them as you wish. For instance, enter a negative trajectory duration to compute backward trajectories, change the arrival time, or adjust the vertical motion method. Then click Run. Tropolink provides tools for an initial exploration of the computed trajectories using Jupyter notebooks with Python and R. In the notebook, you must run each code cell sequentially. In the second cell, you select the study you want to analyze. Then the code will allow you to visualize the trajectories date by date. You select a date, and after executing the subsequent cells, you'll see the corresponding trajectories. Selecting another date will update the visualization accordingly. Finally, note that the Help tab gives access to detailed information about HighSplit and Tropolink references, as well as a short FAQ. Thank you for your attention. We hope this video has helped you understand the functions of Tropolink and that you can make the most of this application for your research. Watch our second video tutorial, which explains how to extract and analyze connectivity data. See you later!